If you've made it this far, congratulations. In this video, we will be rendering something to the screen. We're going to do that by writing a shader which will understand when you take a point in space, which in our case is the position of a star, it will know to create a quad around that star, and we can decide how big that is. Now the quad's always going to be facing the camera. So we got to think about how we're going to do this. Let's say, for example, we have a star, which at this point is a point in space. It's coordinates. For 3D or even 2D rendering, you need to know how big something is. We can't just have it like 1 pixel wide, for example. So here's our camera. Now our camera is looking at the star, and we'll call that the z-axis. What we need to do is we need to figure out, or we need to have a function that'll say, okay, what's the y-axis of the star relative to the camera, and the x-axis. So there's your x, there's your y, and then once we have those, we can say, all right, well, let's draw a quad that'll be, let's say, up on the y-axis, and so it would be like here on the y-axis and here on the x-axis. So we'll draw a point there. Okay, that'll be our first point. Then we'll draw another point down here, which would be that first point will be, let's say, for example, 1, 1. So 1 on the x-axis, 1 on the y-axis. Then this, I realize I'm pointing at things. Okay, so this bottom one that I've just drawn here, that'll be negative 1 on the y-axis and 1 on the x-axis. Now we'll draw another point, which will be -1, -1, -1, and the final point will be -1 on the x-axis and 1 on the y-axis. Okay, so that's our 4 points. That'll be the quad that we're rendering. It's a really useful thing to know how to do. There's all kinds of applications for writing what we'll call billboards, or taking a point in space and drawing an object where that point is, or drawing a quad where that point is. Of course, once we have that quad, now this is called a geometry shader, because we're taking one vertex as an input, and we're putting out 4 vertices as an output. So we're changing the geometry of the shader. Once we've done that, we're going to have a quad to work with. Then we'll use a fragment shader to turn that quad into a circle. Okay, so we can do that by saying for every point in this quad, we'll be able to say how far away it is will determine how much alpha, or how much opacity it has. So if it's say in this corner here, it's going to have an opacity of 0. You won't be able to see it at all. But if it's right in the center, this would have an opacity of 1, or an alpha of 1. So it'll be absolutely drawn. It would be very opaque. So that would be 0. That would be 0. That would be 0. That would be 0. This would be 0.5. You sort of get the idea. Okay, so let's go ahead and write our shader. Let's see. I'll open up our project. So I'm gonna go ahead and create a new folder in my assets folder. I keep it separate from the scripts because it's not in C#. It's kind of assets, shaders. You kind of think of it's a bit different. Just go shader, shaders. Okay, we're gonna create 2 files. One of them is going to be called star.shader. That'll be the shader specific to creating stars, our star billboards. The other file we're going to create is called utility. Utility.cginc, or in other words, CG include file. So this is a few little functions that we're going to be using for our star shader and our constellation shader. Okay. Let's see. I'll start by writing the star shader, and then we'll come back to the utilities. Okay, so start off with a line. Could say shader. Now this will be the name of the shader that'll appear in the materials menu. Starchart. Just call it star. All right, we're going to have one property for now. This property is going to be called radius. Got star radius. It's going to have a range of 0 to 10, and we'll start off by giving it a radius of 2. All right, and now we write our sub shader with one tag, because this is going to be this is a transparent object. In other words, we want to be able to see stars behind other stars. We're going to just put it in the transparent queue. So they say queue equals transparent. This is the order in which the shader will be drawn. So the solid objects will be drawn, and then transparent objects will be drawn in case they want to be in front of drawn over those solid objects. Now we're going to turn off Z writing. I'll write it in. I'll comment it out so we can see what it looks like without it. It'll be easy to explain it by just showing it. And also we're going to write blend source alpha 1 minus source alpha. This is about if there's a star already drawn, how do we draw a star in front of it, and how do you blend those two colors together? Blend. Okay, and now we're going to write our pass, open brackets. We're going to start a CG program. We're going to write a vertex, so pragma vertex vert. We're going to write a geometry and our geometry geom and our fragment frag. Okay, this is the frag. This is declaring our three programs. Okay, we're going to include unity cg.cginc. We're also going to include utility.cginc. That'll be our utility class that we'll write later on. Okay, now we're going to write our data structures that'll be passed from the mesh to the vertex shader, then from the vertex shader to the geometry shader, then from the geometry shader to the fragment shader. Okay, let's start off with app data. So struct app data. This will just have a float for pos, and that's going to be a position or SV position. And we're going to write our struct vertex to geometry, so V to G, and that's going to have the same. And we're also going to have our geometry to fragment, so G to F, which is going to have a position as well as a UV coordinate. So UV float 2 UV is text coord 0. Okay. All right. So now we can write our vertex shader. Okay, vertex shader. So vertex shader really it's not going to do anything in this case. It's really just going to pass that position from the vertex shader to the geometry shader. All right. So we say v2g vert. We're going to pass in the app data v. We'll say g to f. Is that right? Yeah. No. Yeah, no, sorry, V2G. V2G, we'll just say O for output. And we say O dot pos equals V dot pos. And we'll just return O. That's about as simple as your Vertex shader can get. You might, if you've written shaders before, you might be used to doing a object to clip matrix transformation here. The reason why we're not doing it is because we need to find out those offset positions first before we make that conversion. All right, now we're just gonna declare that radius variable. So float underscore radius. We'll say G2F geom. All right, now this is where it gets a bit interesting. This is where we get the syntax of our geometry shader. First of all, we need to say how many vertices are you going to be giving back out of this shader. So we say max vertex count is equal to 4. Is that right? Yeah. Oh, sorry. Okay, so that's our max vertex count. We're giving four vertices back out. 1, 2, 3, 4, because it's a quad. Okay, now we're going to say how many are we taking in. We say point v2g. This will be an array. It's going to be called in, and it's an array of the length of 1. So for each point in this mesh, we're going to have each point will have its own geometry shader. Okay, now we're going to have an in-out triangle stream of type G2F. Tri-string. Okay, that means that it's we've got this object which we can append more values to. We'll see what that looks like in a moment. Okay, so now we're gonna first of all we're gonna declare our 4 points. So we just say float for. Now when I say declare our points, I mean the positions of our new vertices. So we'll call it verts, and that's got a length of 4. And this is where we're gonna say where are those verts going to be. So first step we need to do is we have that one position, and we need to find out how far to offset on each side for these new vertices. And for this we are going to use our utility class, because we'll be using these same functions for the constellations. Okay, so in our utility class, we're first going to do a little bit of what do you call it? Responsible or good programming, good etiquette. We're going to say if pragma if and def utility define utility and end if. This is because let's say later on we get more and more complicated. If we try and declare this same class twice up here in this include, if let's say we include utility and then utility included something else which included utility, then the compiler would have a bad day. So we say only if it hasn't yet been defined, then we'll do this next part of the code. All right, this is also going to include unity cg.cg include. And the first one we'll do is we need to figure out we need to take each point and then get the offset in world position, and then what we need to return is a clip position for each of those points. So we're going to do that matrix transformation of this isn't really a video about that, but yeah. We'll start writing it, and I'll explain what needs to be explained as we go. Okay, void world point to clip billboard. Okay, float for pos. So this is the original position of that star. We have a float which will be the scale, how far to offset how far to offset our quad that we're creating. And also we're going to have an out float for verts. Okay, so what we're doing here is we're saying, I want you to, let's see, I can't really reach it. I want you to pass in the position here, pass in the position of the star. Tell me how far away from the star in each direction you want it to go. And also pass me in an array of vertices, which I'm going to fill out with their new values. All right. So now that we have this, the first step we're going to do is we're going to figure out, I wish I still had that drawing. What we need to do is we need to figure out, relative to the camera, the up and the right positions, right? Which luckily Unity has a really helpful built-in function for. Okay. So we'll say float 3, which will be, a vector 3. You can think of it like that. And right, this will be right. So this is the x-axis. It's going to equal, let's see if I can get this, normalize Unity underscore matrix underscore inverse transform, I think, IT, underscore MV, model view. Okay. 0.xyz. All right. So that's going to give us a normal value to the right, facing the right direction of the camera. And now we're going to multiply that by scale. And we're going to do a very similar thing for up. But instead of the first index of this array, it'll be instead of 0, it'll be 1. So 0 and then 1. Okay. So now we've got our right and our up of our directions. So now we just need to say, okay, from that position, give us some amount to the right, some amount up, and then convert that, because this is in world space. We need to convert that to clip space. Okay, so I'm going to create a new function. This is going to be called object to offset clip pos. And we're going to pass in the vertex. We're also going to pass in the offset. So that vertex is the original position. I'll call that pos. Yeah, so that's the original position. And he's saying how far in which direction you want it to go. Float 3 will be the offset. Okay. And then we're going to convert that to a clip position. The clip matrix. Okay, so we say float 4 v is equal to new float 4, which will be the position plus the offset, and we're going to pass in a 1 for that last value. We're going to return Unity object to clip position and pass in that v. This 1 has to do with matrix transformations, a subject that I'm not terribly confident in, so I won't comment on it. But yeah, what this is going to essentially do is this is going to translate that start position plus some offset into the clip position, which is what our fragment shader will use to draw the points. Okay, so now for each of these vertices, we're gonna apply this function to it. Okay, so first of all, we'll say verts 0 is equal to object to offset clip pos position, and then this is where we figure out. It's kind of like, okay, one of them's going to be negative on the right and negative on the up. One's going to be positive on the right, negative on the up. The other's going to be positive on the right. You know what I mean? We're drawing 4 points as offsets from that original star position, and it is important to get this order right so that they're drawn in the right way. They're drawn facing the camera. Okay, so first of all, we're going to go negative right and positive up. The second one, say 0, 1, 2, 3. The second one is positive right and positive up. Third one is negative right and negative up. And the last one is positive right and negative up. Okay, so that's going to fill out our vertex values. Now we will be able to go back to our star shader and apply this function to our verts. All right, so we'll go world point to clip billboard. Okay, we'll pass in that underscore 0 you remember this is an array, and we're only getting that first value. It's an array of one length, and we're going to pass in underscore radius as the scale, and we're also going to pass in the verts. We've got to say out verts, which essentially means you'll notice that this function we're not returning anything because it's doing its work on the verts inside that function. That's only because returning arrays inside functions within shaders can be a little bit messy, a little bit difficult. Okay, so now we have our 4 vertices, our 4 points. All we got to do now is append this triangle stream with those positions, with those new points. Okay, so we're going to create one G2F object. We're just going to say G2F out. Okay, well now we'll say out.pos equals verts 0, out.uv equals float 2. Got to get, this is another bit where we got to get the order right. 0, 1 for that one, and then we say try stream dot append out. Okay, now we're going to do that 4 times. Verts 0, verts 1, verts 2, and verts 3. And for the order of the UVs, we're saying 0, 1, 1, 1, 0, 0, 1, 0. Okay, that's everything for our geometry shader. Now we just need to do our fragment shader, which at the moment we'll make really simple, and then once we get everything's working, once we fix all our compile errors, we'll come back and make it a bit prettier. Okay, so we'll say fix for, that's what's getting returned, which will be a color. Fix for frag, this will be a G2F, will be the input. Let's do a little tag here, SV underscore target. Okay, we're just going to return, for now we're just going to return white color. Oh, white's a bit boring, wasn't it? Well, let's do cyan, which would be 0, 1, 1, and 1 for the alpha. Alright, now make sure we end our CG program. And let's go see how many of these, see what Unity reckons of our handwritten shader. Let's see, start Unity /assets /scene /main.unity. All right, how's it going? Is this sort of starting to like make sense? I know there's a lot here. Syntax error at line 5. Pass unexpected undefined. All right. Let's have a look. Line 5. Oh, yep. No semicolon there. Okay, I wonder if that was everything. Okay, so we've got our star and our utility. Let's go ahead and create a new folder. We'll call this materials. Create a new material. We're going to call this star. And we're going to go ahead and add our star shader, which isn't showing up, is it? Not supported. Okay. No? Failed to compile. All right. Let's see. I'll do a little cheat. If something's not working here, what you can do is you can go ahead and press space, then save it again, and it'll reconsider what it was. Okay. Line 11. 1 minus source alpha. Yep. Okay. Does that get it? Not yet. Both vertex and fragment programs must be present in a shader snippet. I think there are both. CG program. Is that right? Let me just check my notes. Vertex vert. Fragment, vertex, vert, geometry, fragment, fragments, frag. Okay, unexpected token. Oh, yep. Oh, for each of these structs, they're going to need semicolons. Unrecognized identifier, G2F at line 45. G2F geom. Let's see, is it because I haven't... Might be because I haven't put a semicolon at the end of the vertex shader. No, that's not right. Oh, G2F. I've renamed that wrong. G2F. Okay, G2F. I should have fixed that. Oh, G2G. Whoops. G2F. Okay. World point to clip billboard. No matching 0 parameter function. World point at line 45. World point to clip. To clip billboard. Okay, what's going on there? Unexpected token out at line 49. Oh, did I forget to leave that? Yeah. No? Is that right? Oh. Oh, whoops. I'm not supposed to write an out there. Cannot convert to struct v2g to float 4 at line 49. Oh, in 0.pos. That should be. Geometry shaders can't return values. Output must be written as streams at line 45. Oh, right. Void. That should be a void. Okay. Probably want position instead. Okay. Position. All right. It's that easy. Goodness. If you're still watching, then congratulations. So now we set our star chart shader to our star chart material, our star shader to our star material. And now we can go ahead and in our procedural assets, we will select our star prefab generator. In this material, select the star material, go ahead and press generate, which will give us our star prefab, which you can already see these little cyan objects here. So if I go ahead and drag that into my scene, we've got a big square, which is exactly what we wanted, and a few other squares around. Okay, this is beautiful. This is exactly what we want. So this is it's finding for each star. It's drawing a quad, and they're in this lovely cyan color. All right. So the next thing I'm going to do is I'm just going to make it look a bit prettier. I'm going to give them circles instead of squares. So how we can do that is we can write a little function to get how far away. Remember, we're talking about this quad, and we're saying the further away something is from the center of the quad, we want it to be more transparent. So let's first of all get the distance from the center. Okay, so we can say we'll say float dist is equal to the length of the UV, and we're going to subtract from that 0.5. 0.5. The reason why we're doing that is because the UVs go from 0 to 1, or 0 to 1. Yeah, because it's reversed. I believe it's. Oh, I can't. Yeah, 0. Anyway, 0 to 1, one way or the other. And we want to say from the center to the edge. So we'll subtract 0.5. So everything's like from negative 0.5 to 0.5. And then if we multiply that by 2, it's going to be from negative 1 to 1. Okay. And now that distance is going to be some value from the edge, from one edge, which would be negative 1, to another edge, which would be 1. The thing is that if it's in the bottom corner, that's going to be negative 1.4, because, or about 1.4, because that's like it's further than 1, right? Because the distance on the x would be negative 1, and then you also go down for the y. So what we're going to do is we're just going to clamp this value. Okay, so we'll just say, what's what happened here? All right, so we'll just say float clamped dist equals clamp dist between 0 and 1. Yeah, right, because it'll never be, the distance rather than the position. It'll always be a positive number. Okay, and now we're going to get the alpha, which will be the inverse of the distance. In other words, it'll be 1 at the center and 0 on the edge. Okay, so we just say float A for alpha is equal to 1 minus clamp distance. Clamp distance, and then we're going to pass in that A for that final value of our fixed wall function. Okay, missed a semicolon, did I? Oh, I missed a bracket. Okay, length of UV minus that value. Yeah, okay, so get the length and then multiply that by 2. Okay, so there we have it. We have our lovely glowing stars. Oh yeah, and the last thing I wanted to show you was that Z right. You can see how make sure that's nice and big. You can see how if there's a star behind this front star, it's being blocked like that. You can just see that happening. That's because they're writing to the Z buffer. So they're saying only draw me if there's nothing in front of it. And this front object, this big one, is saying, write me to the Z buffer, so don't draw things behind it. So what we're going to do is we're just going to say, don't write to the Z buffer, so you'll be able to see objects in front of each other. So Z right will turn off, and now we'll have them blending really nicely. You see them through each other, and yeah. Okay, look, if you made it all the way through this episode, well done. Congratulations. I might do another video that'll be simpler, just explain the code rather than watching me go through it all.